Okay, we are going to go over how to do synthetic division. Now, synthetic division is merely an alternative for long division. Long division will always work, but synthetic is often shorter and quicker and less prone to mistakes, and we want to avoid those. The caveat, though, here is that synthetic only works if you have a binomial divisor, so like this here that I've got. With x plus 2, and the x can't have a coefficient. So for instance, I couldn't have 2x plus 1, even though that's a binomial. So there's kind of, this caveat in that it's really specific in what it can use. It must be a binomial, and the coefficient on the x must be 1. Now it's pretty easy to rewrite something like 2x plus 1. This can also be written as x plus 1/2, and then I could use this 1/2 to do it. So there are ways around the coefficient. There isn't a way around anything higher than a binomial. Now, if you do want to use it for the lower, and this works, this is a really useful tool for checking roots in the rational root theorem. You take the opposite. You really are solving x plus 2 for 0, so you're going to use -2. And then you use the coefficients from this as is. Now the rule is you have to have every coefficient, just like long division. So if, for instance, that -x² wasn't there, I'd have to put a 0 in. So I can't, skip as I go down. I have to start from the highest exponent, the degree, and work down by ones and fill in with zeros, just like long division. So that rule still stands, and I do still have to be in order. So I can't decide that I'm going to put the 20 where the 8 is and, flip-flop them. That doesn't work. So again, those are the rules that we already knew from long division. So now to do synthetic, the first thing I do is I bring the first number down, the 3, straight down. Nothing to it. Whatever it is, the first number just comes down. Then I multiply this number by it. So -2 times 3 is -6. Then I add these, -14. Same thing here, 28. Add them. So that's 8, -16. So this is 0. This means that this is a root. The x plus 2 goes into this. And my answer, if I did doing the division, my answer now, I'm going to put this back in regular form. I start 1 degree lower, so I was x to the 3rd. I started x², and I just fill in. And if there's any zeros, I just skip that one as I count down. So this would be the answer to this division problem. 3x³ minus 8x² minus 20x plus 16 divided by x plus 2 is 3x² minus 14x plus 8. And if I was looking for roots, this is a 0. -2 would be a 0 of this equation. So hopefully that shows you synthetic. As I said, long division always works. It's not going to go away. It's just a quicker method, and especially like, for instance, testing for roots with the rational root theorem to find all your zeros. This can really speed up the process, so that's where it comes in useful.